Hi everyone, this is Sujatha, Assistant Professor of Mathematics, K.S.Rangasamy College of Arts and Science Autonomous. In this video, we are going to discuss about some fundamental concepts in graph theory. Graph theory, in last 3 decades, graph theory becomes popular because of its wide variety of applications in various fields such as physics, chemistry, operational research, engineering, computer science, etc. Graph theory, the first paper in graph theory was written by Euler in 1736. On his day, the unsolved problem, Königsberg bridge problem was the famous one. After that only the graph theory grew very fast. Many research works are going on in graph theory nowadays. First we are going to see what is a graph. A graph is a diagram of points and lines connecting to the points. It has at least one line joining a pair of vertices with no vertex connecting itself. If a vertex connecting itself, it is called as loop. In a simple graph, loop is not permitted. The concept of graphs in graph theory stands up on some basic terms such as point, lines, vertex, edges, adjacency and properties of graph theory, etc. Here we will discuss some basic concepts in graph theory. First, definition for point. A point is a particular position in one-dimensional, two-dimensional or three-dimensional space. For better understanding, we are denoting the point by an alphabet. In the example, a point is denoted by the alphabet A. And line. Line is a connection between 2 points. Always line is represented with a solid line. In this diagram, the vertices A and B are connected by a line, and this is called the line AB. Next, vertex. Vertex is just like a point, the point where multiple lines can meet at a point. It is also called a node. Similar to points, a vertex is also denoted by an alphabet. And edge. Edge is the mathematical form of a line. It is the connection between 2 vertices. Many edges can be formed from a single vertex. Without a vertex, an edge cannot be formed. There must be a starting vertex and ending vertex for an edge. And in this example, A and B are connected by an edge AB. Next definition, graph. A graph is an ordered pair V, E. Here V is the set of all vertices and E is the set of all edges in a graph. See this example. In this example, 4 vertices are given, A, B, C and D. That is A, B, C, D are 4 nodes, points. From these 4 nodes, 4 lines have been formed, and AB, AC, CD and BD are called as edges. In the next example, 4 vertices are given and edges are given AB, AC, CD. There is no edge between B and D. Loop. Loop means an edge joining from a vertex V and ending at the vertex V. So an edge joining a vertex into itself is called as a loop. In second example, there are 2 loops. At the point A, one loop, and at the point B, another loop have been formed. Next, degree of a vertex. Degree of a vertex means the number of edges. How many edges have been adjacent to the vertex V? And it is denoted by DEG of V. That is, degree of a vertex is denoted by the term DEG of V. In a simple graph, what is simple graph means? A graph having no loops and no parallel edges is called as a simple graph. In a simple graph with n number of vertices, the degree of any vertex will satisfy the condition. Which condition means degree of V is less than or equal to n minus 1 for every vertex V in the graph G. Suppose if there are n vertices in a graph, every vertex can connect with at most n minus 1 vertices in that case if there is no loop. So a degree of every vertex is at most n minus 1 in any graph. And degree of vectors can be considered under 2 cases. First case, undirected graph, and second one, directed graph. Directed graph means a graph in which each edge is represented with direction is called as directed graph. Otherwise it is called as undirected graph. Degree of a vertex in an undirected graph. See this example. In this example, the edges are denoted without direction and the degree of the vertex A is 2 because from A there are two edges connected. One is connected with the vertex B and another one connected with D. And degree of B is 3 because from B 3 edges connected to A, C and D. But there is no edges from the vertex E. So degree of the vertex E is 0. If a degree of a vertex is 0, it is called as isolated vertex. Suppose the degree of a vertex is 1, that vertex is called as pendant vertex. See this example. In this graph, degree of A is 2 and degree of B is 2, degree of C also 2, degree of D 2, but degree of E is 0 because E is not connected with any other edge vertices. So the degree of the vertex E is 0 and it is called as an isolated vertex. There is no pendant vertex in this graph. Degree of vertex in a directed graph. In a directed graph, each vertex has an in degree and an out degree. In degree of a vertex V is the number of edges which are incident into the vertex V and it is denoted as degree minus of V. Out degree of a vertex. Out degree of a vertex is the number of edges coming out from the vertex V and it is denoted by degree plus of V. Consider the following graph. In this graph, direction is mentioned and the number of edges coming out from the vertex A is 2. So the out degree of the vertex A is 2 and the number of edges coming out from the vertex E is also 2. So the out degree of the vertex E is 2. Like that, the in degree and out degree are mentioned in this graph. The in degree and out degree of other vertices are shown in the following table. The in degree of A is 1 and out degree is 2. In degree of B is 2 and out degree, there is no edges from B going out from B, so the out degree of B is 0. And in degree of the vertex C is 2, out degree is 1. In degree of the vertex D is 1, out degree is 1. In degree of the vertex E is 1 and out degree is 1, like that. The in degree of the vertex G is 0 and out degree is 2. It is taken from the previous graph. See this another example. From the vertex A, there is one edge coming out from A and it is connected to E. So the out degree of the vertex A is 1 and out degree of the vertex B is 2 because B is connected to the vertex A as well as with the vertex C. But there is no edges out from the vertex C, so the out degree of C is 0. For the vertex V, there is one edge coming out from D and one edge coming inside of D. So in degree of D is 1 as well as out degree is 1. The in degree and out degree of other vertices are shown in the next table. These are the in degree and out degree of the vertices which is shown in the previous diagram. Next, adjacency. Adjacency of a vertex means the number of edges which are adjacent with the vertex V. That is, the number of edges incident with the vertex V is called as adjacency of the vertex, given vertex. Here the adjacency of vertices is maintained by a single edge that is connecting those two vertices. In a graph, two edges are said to be adjacent if there is an edge between the given two vertices. In this example, between the vertices A and B, there is one edge. So the adjacency of A is 1 and adjacency of B is 3 because 3 vertices are connected with the vertex B, and adjacency of C is 2 because B and F are connected with C. Like that, the adjacency of other vertices are mentioned here. In this graph, A and D are adjacent vertices as there is a common edge AD between A and D. C and B are adjacent vertices, but B and D is not adjacent because there is no edge between B and D. So B and D are non-adjacent vertices. Next, parallel edges. Parallel edges means the edges the edges connecting between two common vertices is called as parallel edges. In the above graph, A and B are two vertices and A and B are connected by two edges. So this is called parallel edges. Multigraph. Multigraph is a graph where the parallel edges occurs. In this graph, C and D are connected by parallel edges, so this graph is called as multigraph. In this example, the vertices B and C have two edges. The vertices E and D also have two edges between them, hence it is a multigraph. This is another example for multigraph. Degree sequence of a graph. Degree sequence of a graph means the degree of each vertex can be arranged in ascending order or descending order. This arrangement is called as degree sequence of a vertex. See this example. Here the degree of A is 2 because two edges are incident with the vertex A, and degree of B is 2, degree of C is 2, but degree of D is 3 and degree of E is 1. The degrees are mentioned here. The vertex A is connected to B and C, so degree is 2. Vertex B is connected to A and D, so degree is 2. Vertex C is connected to A and D, so degree is 2. And E is connected to D only, so degree of the E is 1. The degree sequence is 2, 2, 2, 3, 1. In this example, the degree sequence of the given vertices are 2, 2, 2, 2, 2, 0. So far, we have discussed some basic concepts in graph theory. The other concepts, important concepts, will be discussed in our next video. Thank you.